Welcome to part 3 in this series of videos where we look at cascading grids in a Blazor application. We need a way of adding and maintaining database records. These techniques are what is known as CRUD operations. CRUD is shorthand for create, read, update and delete. Entity Framework is the conventional tool for achieving database operations in .NET and C#. But this seems to me to be unnecessarily complicated and difficult to understand. We will therefore be using a library called Dapper in place of Entity Framework. Using Dapper, we create a service and interface for each of our model classes, where each model class represents one of our database tables. The pattern we establish for our first model class can then be used as a template for the other model classes. In summary, we will have one service class per model class and one interface per model class. Within the service class, we will then have one method per CRUD operation. So at its simplest, we will have one method for create, one for read, one for update, and one for delete. We will be using the project class as our example. So let's make a start and have a look at the code. Open Visual Studio if it's not already. The first thing we're going to do is to create the two files we need, the service file and the interface file. To do that, right-click on the data folder, select Add and select Class. And we're going to be doing this for the project model class, and the convention is that we call the service the name of the model class plus service. So we've got project service.cs, and I'm also going to add the interface file now before we go any further. So right click, add class, this time it's interface, and the convention here is we start with a uppercase I and then the name of the service class. So iProjectService.cs. We'll now go back to the project service class, and the first thing we need to do is to add some using statements at the top. We're using Dapper, so we need to add the code to use that. So I'm just going to paste this in. So we've got using Dapper, using system.data.SQLite, and using system.data. The next thing is that I want to link the service file with the interface. So I do that by simply adding colon and then iProjectService. We'll now add some code to enable the reading of the configuration, i.e. appsettings.json, to enable the connection string to be determined. We'll then follow that with some general declaration of variables used throughout the service class, and then a method for each of the CRUD operations. So we'll start by putting in the code to read appsettings.json, and again I'll paste this in. And to be honest, I don't know exactly how that works, but it works, and so I'm going to be quite satisfied with that. We're now going to add some code to declare variables that we'll need throughout the service. And these are, we're going to need a public string, which I'm going to call connection ID, and I've set that to equal default, and that will read from the appsettings.json the connection string that we have called default. We're going to need a SQL command for each of the CRUD operations. I'm just declaring it here and setting it to an empty string. And we're also going to need a variable called project of type project. I'm now going to put some placeholders in for the names of the CRUD methods that we will need. I'm going to use the convention of using the name of the the model class, and then the operation that we need, such as project create, project read, project update, and project delete. We'll look at project create to start with. And the method that we need for this will look similar to this. So this is the method. It's a public asynchronous task of type Boolean, which I'll come back to in a second. And I'm calling it project create, i.e. the name of the model class plus the operation. And we're going to be passing into this method an object of type project, which we're calling project, and that'll come from the code that we create later. We will be passing some parameters to the SQL statement used later in this method, for example, the name of the project. So next we declare a var type variable, which we will call parameters of special type dynamic parameters. Dynamic parameters allows us to pass any number of parameters and with types that will be defined later. So we add this line in here to declare that. And we can now add the parameters we need to add the new project. Each parameter definition requires a parameter name, which we prefix with the @ symbol, the name of the object being passed, and its type. So for creating a project, we need this code. So we've got the parameters, this var called parameters, and we're adding to it @project name, which is the name that we want to call the variable. It's coming from project name, which is being passed in, and its type string. Similarly, we're adding the user email. We now need to assign a value to the SQL command. As the name suggests, this is the SQL command we want to send to the database. This is a straightforward SQL command to insert a record. As part of this, we will be passing the dynamic parameters previously declared. The text for this SQL command is this. So it's a straightforward SQL command saying insert into project, and then we're putting in the column names, project name and user email, and then we're passing the values, which will be the variables we declare up here. Having declared all the variables required, we can now make the connection to the database and execute the SQL command. The code we use is this. The using line gets the connection string and opens the connection. Using the using statement ensures that the connection is closed once the command has been completed. The execute async is the one that does the hard work, executing the SQL command with the dynamic parameter variables. In this case, the project name and user email. And because we said it's type bool, this will return either true or false. Either the create a record will succeed or it will fail. If it succeeds, we're going to be returning true. Otherwise, it will return false. So this is the pattern that we'll be using for the other methods for read, update, and delete. We always set up the variable called parameters. We add the parameters, we work out what the SQL statement is, and then we finally make the connection and execute the SQL. So I can now go to the other placeholders and add the code we need. I'll come back to project read because that's slightly different. So for update, we have this code. So it follows exactly the same pattern. Declare the variable of dynamic parameters, add the parameters, work out the SQL command, make the connection, and then execute the SQL command. And for delete, again, exactly the same. I should have mentioned that for update, we're passing in the object of the whole project, but for delete, we only need to pass in the project ID. And there's a specific command here, a specific SQL command, which we need for SQLite, and that is this pragma foreign keys on. And that's to allow the delete cascade to work, which we'll come back to later. So those, as I say, all follow the same pattern. Read is slightly different. So let's have a look at read. Read is different because we're passing in an IEnumerable of project. And I'm calling this project read all. We'll later want to probably read just one or two records, but in this case we want to read them all, and therefore we need an IEnumerable, which is effectively a list or collection of data. So we declare the IEnumerable of project, called projects. The SQL command is select asterisk from project, and I'm ordering it by project name, although there's no particular need for that. We're making the connection as usual, but this time we're doing a query async as opposed to an execute async, and we're getting a collection back. So we're going to return this object called projects, which is the IEnumerable. So that's the service, but we haven't finished yet. We need to add the interface to make the service work. So we need to open iProject service, and in here we have one line per method that we're using in the service. Luckily, it's quite simple. So we just add effectively the name of the method without the public async in front of it. So for the read all, we've got task IEnumerable project read all, and that's what we've got in the interface. But we still haven't finished. The last step is to register the service in Program CS. So open Program CS, and in this section where we add services to the container, we need this line. I'm using add scoped here. There are other options, and they are either add transient or add singleton. I don't think it makes much difference which we use, and I tend to use add scoped as the default. And I'll put a link in the description to an article with a discussion on this, but we don't really need to know more than that at the moment, so we'll just stick to add scoped. So we've now added the service interface and registered the service for the project class. We now need to add similar files for the other model classes. So for example, or not for example, so we'll need to add them for room, wall, and deduction. But they will follow exactly the same pattern. So I'm not going to demonstrate that, but we will just add them. I'll put a link to the code that we need in the description. Before we finish, we ought to save our files and just check that the project still runs. So save everything and run. Excellent. That seems to be working, and we don't seem to have broken anything. So back to the code. So we've got the methods for maintaining data, but we haven't got a page to actually do any of that. And that's what we'll look at in the next video. I'll put a link in the description to a blog post where I give a full description of what I've done here, and where you can also get the code. The next task is to add a page to maintain the data, and we'll look at the project page first, but that's for the next video. Thank you all very much for watching.